Now, let's go ahead and make our VirtualBox virtual machine a bit more usable. By now, you've probably noticed that the window that shows up for our virtual machine is pretty small, and that expanding the window doesn't make it any larger, nor does maximizing it. You're limited in your ability to make changes to your virtual machine settings while it's running, so go to File and hit Close. Now you have a couple of options: save the machine state, send the shutdown signal, or power off the machine. Saving the machine state means that when you power the virtual machine back up, your tabs in Firefox, Terminal, and other activities will be open to the state that you last had them. If you power off the machine, that means it will completely start and close out of all of your applications. Select Power Off the Machine and click OK. Go ahead and select the virtual machine you want to change the settings of, and click Settings and Display. Now, under the Graphics Controller setting, I'm going to change from VM SVGA, which stands for Virtual Machine Super Video Graphics Array, to VBox SVGA, and click OK. I'll put some links in the description to help you choose which graphics controller option to select. Next, reopen Settings and select General, Advanced. What this setting does is allows you to copy-paste from your virtual machine into your host machine, and from your host machine into your virtual machine. In order to configure a shared clipboard between your host machine and virtual machine, you're going to need to download and add an extension pack for your VirtualBox. First, you need to make note of what VirtualBox version you have. To do that, go to Help, Contents, and take a look at the version right here. I have 6.1.4. Next, navigate to the link in the description, download.virtualbox.org/virtualbox. Find the link that corresponds to your version of VirtualBox. Go ahead and download the extension pack and make note of where it's saved to. Go back to the VirtualBox Manager and select File, Preferences, and Extensions. Click the plus button and navigate to where you saved the extension pack. And click Open. When this pop-up window appears, go ahead and click Install. Agree to the license agreement and wait for it to install. Click OK and navigate to Settings, General, Advanced, and switch from Disabled to Bidirectional Shared Clipboard and click OK. Now, let's take a look at our network settings. Within Settings, go to Network and expand Advanced Options. Now let's take a quick look at our options. We've got attached to NAT, N-A-T. That stands for Network Address Translation. NAT means that the virtual machine is translating all of the internal IP addresses to a single IP address out. If you've ever seen the joke, there's no place like 127.0.0.1, that's what it's referring to. Any IP traffic originating within your virtual machine or within the host machine are going to have an IP address or Internet Protocol address starting in 127. The NAT takes all of the traffic from your virtual machine and translates it to an internal IP of your host machine. This means when you open up a web browser on your host machine and navigate to the web server of your virtual machine, You don't need to specify an IP address. You can just type localhost, and the NAT takes care of telling your web browser where to go look. This also means that if you have an external computer outside of your host computer that's wanting to access the content on your virtual machine, it's going to act as though it's seeking out the web server on your host machine. Next, we'll need to configure something called port forwarding, but before we can do that, we first need to determine which ports we need to forward. To do that, we'll need to look in what's called our Docker Compose YAML file. If this is for a production environment, you'll want to look at the options on hub.docker.com/r/openemr/openemr. Select which OpenEMR Docker version you want and click a link to go to the example Docker YAML file. Once you've found the Docker Compose YAML file you want to use, go ahead and look for any fields called ports. As you can see in this file, the only ports you'll need to open up for this OpenEMR Docker are ports 80 and 443. If you're using a development version of the OpenEMR Docker, you'll need to look in a different Docker Compose YAML file. This file can be found in the topmost directory in the OpenEMR GitHub repository. If you go to github.com/openemr/openemr and scroll to docker-compose.yaml, it will take you to this file here. The first thing you might notice under the ports section is that they're not the same on each side of the colon. Whereas in the production OpenEMR Docker, it's always 80:80 or 443:443. This is because there's some port mapping happening inside of Docker. The Docker container sees it as receiving traffic on port 80, but what it's actually getting is traffic on port 8300. Port numbers are traditionally used for certain protocols, but they're not set in stone. By doing port mapping, you can have any number of different web servers all thinking that they're running port 80 when in actuality, they're all serving different port numbers. In this case, both the OpenEMR web server and the PHPMyAdmin web server both think that they're serving traffic on port 80. And they are, inside of their individual Docker containers. The Docker network, however, maps them to two different ports. That way, they both don't have to share. Luckily for us, Docker takes care of this port mapping for us. All we need to do is make note of the ports on the left of the colon. This means we'll want to set up port forwarding for our virtual machine on ports 8320 for MySQL commands, where SQL, spelled SQL, stands for Structured Query Language. For OpenEMR, we'll want port 8300 for HTTP or web traffic, and we'll want port 9300 for SSL traffic. We can go ahead and skip ports 3000 and 3001. Finally, you'll need to make note of port 8310 for PHPMyAdmin. We'll also need ports 9000 and 8000, but we'll get into why later. Now that you've made a note of what ports your version of the OpenEMR Docker needs, let's go ahead and set up some port forwarding rules between your host machine and your virtual machine. Go back to your VirtualBox Virtual Machine Manager, select your virtual machine, and click Settings, Network, and Expand Advanced, and then click Port Forwarding. Click the icon here with the green plus arrow to add a new port forwarding rule. You can leave the name as Rule 1, Rule 2, Rule 3, and so on, but I like to give it a name that'll remind me what the port does. You should be able to leave the host IP and guest IP fields blank. Unless you have a conflict on your host machine, go ahead and set the host port and guest port to the same port number. Double-click to set the rule name. Leave the protocol as TCP, which stands for Transmission Control Protocol. The other option being UDP, or User Datagram Protocol. UDP and TCP is what IP, or Internet Protocol traffic, runs on top of. UDP is typically used for things like audio or video stream, when you're sending a lot of packets over the Internet and it's not super important that they all arrive at the destination and arrive in the right order. You'll want to use TCP when you want to make sure that the data you're sending across the network gets received and is received correctly. Take a look at the links in the description to learn more about TCP and UDP protocols. Set the host port to 8300 and the guest port to 8300. Click plus to add new port forwarding rules until you're done. When you've finished setting up your port forwarding rules, your screen should look a little bit like mine. Click OK, and then click OK again. If this warning appears, go ahead and click Allow Access. The other option that I would like to call out is the bridged adapter. If you select a bridged adapter, you won't be able to access your web server by typing localhost in your host machine's Internet Explorer. Rather, you'll need to actually look up the IP address of your virtual machine on your host machine. On Windows machines, you can use the command ipconfig in the command prompt. On Linux or Apple machines, you'll want to use the command ifconfig entered via the terminal. If I'm going to set up a bridged adapter and I have a smartphone connected to the same wireless access point as my virtual machine and its associated host computer, what I like to do is use an app called Fing, F-I-N-G. The app scans all available devices on my wireless access point, or WAP. The Docker containers on the virtual machine on my host machine will show up under a 192.168 IP address. IP addresses in that range, or anything starting with 10, at least in IP version 4, are considered private IP addresses. That means they don't get transmitted along the outside internet. Within my Fing app, I look for devices that I don't recognize, like a mobile phone or an iPad, or have a name like generic. Having multiple IP addresses indicated by this +1 right here is also a good sign. Another clue is to expand that device and click the Find Open Ports option. Of course, this really only works if you know what ports you're looking for. A standard installation of OpenEMR will require ports 80 and 443. Port 80 is typically used for HTTP servers, and 443 is for SSL. HTTP stands for Hypertext Transfer Protocol, and SSL stands for Secure Sockets Layer. If you're using the development version of OpenEMR, instead of port 80, you'll be looking for port 8300 and 8310. For now though, let's keep things simple and switch from bridged adapter back to NAT and click OK. Now let's go ahead and restart our virtual machine. Once your virtual machine has launched, go ahead and give maximizing the window a try. Now our virtual machine's screen fits into our window. Now before we can start copying and pasting from our host computer to our virtual machine, we need to do a few more things. Open up a terminal window and type the command sudo apt install virtualbox-guest-x11. Once that command is finished running, you'll need to go ahead and restart your Ubuntu virtual machine. Once your Ubuntu virtual machine has come back up, you'll need to enter the command vbox client -- clipboard. Now let's kill two birds with one stone by typing the command sudo docker ps-a somewhere in your host machine and then attempting to paste it into your virtual machine. And click return and type your sudo password. Let's take a quick look at our Docker containers. Our HTTP server lives in the OpenEMR/OpenEMR:/flex image, which according to this command has been up for 9 minutes. Let's test that copy-paste works in the opposite direction from virtual machine to host by typing the following command, but pasting it in a web browser of our host machine. Localhost :8310, highlight it, right-click, copy, and paste it into a browser window of your host machine. To make the terminal more convenient to access, go ahead and right-click on the icon to the left here and say Add to Favorites. Now, instead of having to search for our terminal window, you can just go ahead and click the icon here to launch a new terminal window.